Hello everyone, can you hear me clearly? Alright, so let's start from where we left off earlier. So we were discussing a library called collections. Yeah, that's correct. So, alright, so we are discussing something called collections, and basically it's a library of data structures such as an array list, a linked list, and trees and hash table. Most of these uh, most of these library functions are highly efficient, and have a high degree of interoperability, meaning that there are multiple classes to do the same thing but different level of efficiency. For example, you can you can swap various sorting functions, as well as you can swap various kinds of array list or various kinds of trees in place of each other. That is interoperability. Okay, and at the same time, and adopting extending or adapting is quite easy. Okay, in case, say for example, you want to have your own kind of list or stack, you can extend an existing one and start customizing it. All right, so and other similar lines, interoperability, for example, the interoperability, there is a simple interface of stack, and the implementations are different kind of implementation of the stack, which means you can swap various things in place of each other. All right, collections are basically categorized into three parts. One is interfaces, which are basically a contract saying my array list should provide these functions, and stack has to provide a pop, a push, and a top function. So that is what is dictated by an interface. All right, so library, whenever you are building a library, you basically try to code against an interface. On the back end, what you do is, before you start working on something, you build an interface to promise to a customer that these are the things we are going to provide, and how we are going to provide is our own headache. Maybe we will have different kind of implementers giving you these functionality, but you will you can happily have these functions forever for you. Okay, so no matter what is the implementation of stack, all the implementations would be giving you push, pop, and top. So that is interface. And implementations are the actual implementation of the data structure. For example, a list has to give you an item, a linked list has to give you the item at the head, and so on. Or let me put it the other way, a stack can be implemented using a linked list, or a stack can be implemented using an array. Okay, so in this example there are two implementations of stack. One is by array, or it could be by linked list, so it could be one by linked list. All right, so this way these implementations may vary. There could be multiple implementations of the interface provided by the collections. Now, the third part is algorithms. Algorithms operate upon a particular interface. All right. So, for example, if you are having a sorting algorithm essentially will take an array of elements of any data type, which provides a way to compare two elements, meaning all those elements need to implement comparable, or you can specify your own comparator while sorting stuff. Okay, so searching and sorting, say for example binary search. Okay, binary search is good when you are searching for something in a sorted arrays. Now, so sorting and searching, there are thousands of algorithms for each of the task. Okay, and sorting is just one contract where we say that we can sort your stuff. There could be multiple implementation. Okay, so these are the three main categories of collections. All right. Now, in the collections, this is the general hierarchy. Everything is iterable. Okay, all the data types are iterable, means you can walk on the data from one side to another. So almost every item is iterable. Then there is a collection. Collection extends iterable, means on a collection you can go through one item to another and to another. And a collection is extended by a list, a queue, and a set. All right. List. So the red ones, I don't know if it is a red or green. Is it a green or red? This one, interface. Okay, it's an orange. I'm sorry, I'm a little colorblind. So interface is orange and class is blue. So there are three interfaces: list, queue, and set. For a list, every list has to have a certain basic functions, such as get element at a particular index or add an element. Okay, and all everything which is a list extends from collection, which means it is iterable. And there are multiple implementations of the list: an array list, a linked list, and a vector. Vector and array list are almost the same thing, just that array list has its own internal implementation on what rate the size of array list should grow. You can only specify an initial number of elements. In case of a vector, you can define how should the growth be. Okay. Now there is a data type called stack which extends a vector. All right, that's a different data type altogether. And under the hood we have, similar to the list, we have queue. Queue is being extended and implemented by a class called priority queue. And there is another interface called dq which provides extra functionality over queue. And array dq is the only single implementation. Okay, so you can always say list a equals to new array list, and then you operate upon it. Okay, similarly you can say list a equals new linked list, and then you can iterate upon it. So whenever you are working, you should generally depend on your code. Let me show you how. Okay, this is somebody's code. Let me just switch the workspace to. As a part of practice, you always write your code agnostic of the implementation. Okay, you say list a equals new array list, and then on you use that as a list. Okay, and so on. Similarly, we have set. Set is extended by hash set and linked hash set. Okay, so you'll generally say you will write your whole logic against a set, and in the beginning of your code you will say set my set equals either new hash set and or linked hash set. So you can switch between the implementation at one place and your code will remain as such. All right. So let's have a look at how does an array list looks like. So you say list A equals new array list, and then you print the size of an array list. It says that the size initial size is 0, and then you keep on adding these elements, and then you can see this. So you can so a list basically gives you a function called add and so on. Okay. Also note that the list, the index of a list starts with 0. Okay, so C is at 0, A is at 1, F is at 2, and the moment you add one element at one position, this one will move little behind, which means it will become C, and then A2, then A, and then F. Alright, and then you can remove an element from this list. So Seema's question is, don't we need to define the size of array list in the beginning? No, not really. The beauty of any list is that they grow in size by itself. So array list is not really an array. Array list is a data structure which is an extended library of the data structure. It's not the part of the core Java. It's a library provided by Java. So vector list and array list, there's not much of a difference. They are basically the implementation similar to each other. Here, like here, you can see vector and array list almost the same. Just the internal implementation is a little different. But that's a good interview question. And the way the size grow, that is the difference between a vector and a array list. All right. So generally, in real practice, you will end up using array list, but definitely look up the difference between array list and vector. Okay. So it's not vector list, it's vector, not vector list. But personally speaking, I hardly ever used vector in real life. Okay. Now, so this is clear. Here, the important part is if you pass the object here, then that particular element will be removed. And if you pass an index, then that particular element will be removed. Okay. Yes, the index of the all following items will change. Okay. All right. Now, there are multiple kind of algorithms which are available as part of collections. For example, here you can see shuffle. Shuffle basically randomizes the list. Sort sorts an array list, a list. So a sort function is applied on a list. Similar is shuffle. Then reverse. You have reverse here. Okay. So reverse, sort, shuffle, and minimum and maximum. You can see all of these are algorithms provided by the collection. Now you might ask that on what basis it will do the sorting. How will it identify whether an element of this linked list can have object as well. So on what basis it will sort? Yes, on what basis will it sort? Right? In case imagine that this linked list contains new dog 1, new dog 2, new dog 3 instead of integers. On what basis will collection.sort will order one dog over another? All right. So in this case, when you have an object, you will have to implement a comparable function in the object. All right. You'll have to implement a comparable function in the object. So let's say we have, let me just create a quickly a project. Let me give you a demo. This is important aspect because this is where the most of this reasoning behind comes into play. Now let's say we have a class called dog. Okay. Dog has got a name and a height. So let's first see dog. It has got a name and a height. All right. So all right. Now by default, let's say whenever people are sorting, we can define a comparable. We can say our dog implements comparable. All right. Comparable at dog. And then we'll have to implement that function and we say return o dot this dot height minus o dot height. All right. Now this will return a number which is the difference of the two values. Okay. So this one basically compares. Now let's say we have main and in this we create dog d1 equals to dog and his name is, let's say his height is 1 and okay, there is another dog called DDSS and his height is 2 and there is another dog, okay, and its height is 4. All right. Now when we say and we have dog Arraylist. Let me just try to create a list called dogs equals to new array list, and I say dogs dot add d1, all right, and dogs dot add d2 and dogs dot add d3. All right, so we add the classes required to do this, and that's all. Now when we say collections dot sort and we say dogs, also let's just try to implement toString also, public string toString, and all it does is it returns the name of this dog, right? So basically whenever people will try to print this, it will it will basically be it will basically show the names. Okay, so we say system.out collections.toString collections dot, okay, and let's see what happens. Okay, so in the beginning we have this, and after sorting it should be SSDDFF. So not much of a difference, but the moment you say 8 here, it will return it this way. All right. Now we can define right. Good. When we define new array list, we don't define what kind of object are this. Can we have different type of? Yes, in this array list we can have different type of objects. That's correct. Because it's not type safe. And that's where the errors would occur, and that's why we would require generics going forward. All right, we'll talk about generics after some time. Right now it's not type safe. You can have different kind of elements, and this, when compare to happens, it will not be able to compare these two elements, and exceptions would start occurring. All right, that's why we are not adding different kind of elements in this. Now say you want to sort it. You want to sort dogs by first name now. Okay, now you want to sort these dogs by, okay, by something called. So generally what you do is you define, okay, so you generally define a class called class which implements a comparator. Okay, and this is basically a separate one. It won't impact our definition of the class. All right, now this would, when you apply this comparator, so what we did, we created a new class called Comparator Implementation, or we can say sort, okay, name wise comparator. This is our name wise comparator. Okay, this one says that compare these two dogs by their names. Okay, and after doing this you will see a different output. Now the dogs are ordered by their names. Okay, if you say these are the names, then you will see the one FDD comes first. Okay, here what is actually happening. So in the first shot, it has to order by, okay, let's see what happens. This is correct, right? Yes, you can actually take it out. Okay, you can actually create you can take it out and create a separate class as well. Okay, it's just to being a lazy that I don't have to define another class, another file. I have created a nested class, a private class. Okay, this way this class other people will not be able to use. Okay, so whenever you define a class like this, it's basically an inner class and other people will not be able to use this. Okay, but in case other people, you want other people also to use this, then in those cases you should make it a proper class. Okay, so there what we did was we created a comparator by extending a comparator, and then we implemented a function called how to compare these two elements. Okay, that is something different. All right, so that's how you can customize the behavior of sort. Or similarly, when you are implementing other things like I mean, implementing hash table, using hash table, you can customize the behavior of hash table by implementing a method called hash code. All right, so you can clearly see that first it was not ordered, second it was ordered by the name or by the height of the dogs, and then it was ordered by the name of the dog. All right, so sounds good. Sounds good. Good. Let's move on. All right. All right. So here in all these examples, there was always our type safety at the risk. Okay. Here, let's say, for example, if we had added dogs dot add and we said something, okay, say I added my name and I am of course not one of the dog objects. Here it says immediately when we run it, it says that we cannot compare, we cannot cast dog to string. Okay, why is it so? When it did try to sort and when it tried to do a compare to, the comparison of dog cannot happen with a string, and therefore there is an exception. All right, so which means that this array which is type safe, which is not type safe, always has a risk of these kind of exceptions. Instead of getting a compiler time error saying you cannot add a string into this list, we are getting a runtime error. A runtime error is far worse than a compile time error. Reason being, runtime error will only be discovered in the production, while compile time error will be discovered immediately the user commits the code and somebody runs or tries to build it. Right? So therefore it is was very much required that we say that my array list should only have one data type. Okay? That was one reason why generics was implemented. Okay? Or there were other mechanisms earlier. If you had to make Arraylist very type safe, what would people do earlier before Java came with something like this thing? We will create public class dog Arraylist, which extends Arraylist. Okay, and here we will create all the methods possible in the for Arraylist. We will create things like add public void, add, and dog d, and so on. Okay, and then we will say super dot add d. Similarly, we will create something called dog, returns dog, and get int I. Okay, and we say super, we cast it into super get super dot get I. So basically we created this type safe wrapper on top of our array list, right? This was the older way of doing things, and you can think of close to 40 functions. Okay, close to 40 functions you will have to implement in order to make it type safe. All right, now imagine doing this kind of thing for all the objects. Imagine doing all for each object. For customer, you might have to have customer array list, you might have to have some other things array list, and so on. So we had to earlier basically type this code out and extend an array list. Okay, so Seema's question is, can't we just do a type check when we are adding an element? Yes, we can do an type check, but again, to do that type check, we will have to create some sort of a wrapper, right? The idea is we are not letting the users of our list to add anything arbitrarily. If we have to do a type check, either inside the code every time we are trying to add an element, we keep on doing the type check, or we create a wrapper. This wrapper is essentially a grand way of doing the type checking. All right. Either we have our code something like list a equals new array list, and if my object is instance of dog, then add into my object. Now imagine doing so many conditions across the whole thing. It'll become a mess. It will become a mess. All right. Now every time you have to add an element, you have to put this condition, and that makes your code look ugly. It becomes too much of typing work. Okay, and that's where the need of generics comes into play. That's where the need of generics comes into play. Now let's take a step back and look at a function called reverse. A function called reverse we have just written. So you can see this code. It basically reverses an integer array. What it does is it starts from I equals to 0, and before the midpoint it keeps on swapping the element from the beginning with the last one, right? So I is swapped with array minus array. Okay, this is actually wrong. This has to be I here. Okay, and so on. So you can see that. So basically, we wrote a nice function reverse to reverse an array, and this function has nothing much in it. All it does is picks element from the beginning, does it with the and so on, right? So there's nothing much in it. There's nothing specific to integer. But This temp element is of type integer. Okay, so whenever we want to do a reverse, we just call this and it is reverses our string. And okay, so now if you have to write, you want to reverse an array which is a string, what will you do is you will basically either create another function. You will, what will you do, either you create one more function and try to do function overloading, and we pass a string here, and then we define a string tmp and so on. And okay, and similarly, if we have to do reverse for our dogs, the dog objects, then again we have to define another function which takes dog here, and then we define dog here, and so on. This becomes extremely painful. Our code is no longer usable. So what do we do? What do we do? So one of the suggestion is create a reverse function which takes objects, an array of type objects. All right, like this. It takes an array of type object. Now, the problem with this kind of arrangement is that this is no longer, yeah, go ahead. I'm expecting an answer. The problem with this kind of arrangement is, okay, so one is toString and what else? ToString will not be a problem. This code looks neat, and this is how people ended up doing a lot of things, but there were problems in this code because everything at the end of day extends from object, so everything can be casted to object and then casted back into that, right? Yes, if the objects are of different types, then it will create problems. Now if we could create something of here for sorting, we could create an things like this object, and then we could say new dog and our something, and we could say for, and here we could say a string, and then we could also say a float, right? So this becomes a big problem when you deal with this kind of object. So a a is no longer type safe. And we can put any garbage inside a, and we could put different kind of objects in a, and when we'll try to do something, there will again class cast exceptions here and there. Why? Because we do not know what is the type of an object, and therefore it's no longer type safe. Most of strongly typed languages like Java and C++ and C, a lot of focus is on data type safing, so that we catch the error during the compile time rather than runtime in the production, right? So the solution to this problem was to create, so it's no longer type safe. Okay, now solution to this problem was to create generics. Instead of saying object or anything, we say that while creating instance of my object, you have to provide me the data type. Okay, and how do we say that is by putting something here. You can put anything here, okay, and utilize that as a variable. Right now we just put t. So we can say that my reverse function will only accept object of type t. All right, my reverse function will only object accept the data type t. And what is data type t? The data type with which the my library was instantiated. So what does it mean? When we are instantiating your library, we are specifying that it is of type integer. Okay, so which means this ml, this object which is ml, which is created, will only be reversing integers. If you have to reverse strings, okay, if you have to reverse strings, you will have to do something of this sort. You have to say like this. So I'm saying create my library with the data type string, and all these functions everywhere wherever t is defined, it will be replaced internally with strings. Okay, internally automatically it will replace that data type with strings. So now you can see like this. All right, so if I'm defining, if I want to use only with string, we can say string, and then we can only pass, only pass an array of strings. Otherwise this reverse function will give an error at the compile time itself. Sounds good to you? That is how you use. Yes, it not only throw exception, it will on the compile time it will give you a compile time error saying this is something you is not allowed. Let me give you an example here. So let me just create quickly class. All right, so let's create a class called my library, and then we take this up and do this. All right, now run it. So this is good. The moment we try to, let's say we define another array called a1, which is of type string. All right, I'm just double quoting it to make it a string. Now you look at this. So here, I'm so sorry. Here here is ml dot reverse a1. Now look at this. It says that the method is not applicable, hence it will not compile it. It says that there is an error exists. And if I try to say that, it says unresolved compilation problem, right? So to use ML with reverse, what do I need to do? Just create another instance of this class saying I intend to reverse only string. So for the data type, I created another library, and now I can happily now I can happily reverse the strings. Now you can see that the same thing which is all right. Now you can see that it has been reversed. Sounds good to you? That is what is known as generics, meaning that a same class could be used for different data types, enforcing a type safety. All right, which means similarly an array list, the same way we could always say that we want we want a list L equals to new array list, right? And this array list right now can contain all kind of data types. I can say L dot add this, and I can also say l.add 1 and so on. Okay, and I could say and we could say system l dot toString, and there we have it. Okay, but if I try to sort it, it will give an array error to me. All right, now how can I enforce that we can only store a string in it? So there, while defining it, I say that use only string. Okay, the way we have defined our library, my library, in the similar fashion, Arraylist is also defined. Okay, now you can see that an Arraylist, I clicked on it, so it opened the source code. This is how they have defined an Arraylist. Public class and then angle brackets is that defined. E instead of T, you can put anything. You can also say a and whatever you want to write. We can also say something like T1 T, or any variable name we can put here. Okay, that's not a problem, because most of us now, the moment we say string here, it started giving an error here saying it doesn't accept integer. All right, so that is how we enforce type safety and still use the polymorphism of Java. Sounds good to you? Yes. Now coming back to the real thing. Okay, you remember our stub mapper class? It has those weird things where we were extending things. Yeah. Similar to that, similar to instantiating, we could also say extends. In our example, let's take our example to a newer level. Here, let me just make it a little simple. Here, other than creating an integer class, we could say my string lib. Okay, here this one would extend my library for a data type called string, right? If you remember our case which I was trying to describe to you, that earlier when we had to do type safing, we would extend an array list. Okay, so in the similar fashion, we could type safe. Say we would like to just keep this is my dog library, and I would say my dog library. Okay, my dog library, and then I say dog. That means it will essentially extend my library, replacing the data type and making it rigid for the dog. Okay, all right, now you don't have to do anything much. You can simply start using this library as it was, and we could say, let me just say, okay, we could say my dog library. Okay, my dog library equals my dog library, and add new. Okay, mdl dot, what was that, reverse, right? And then you can see that it is saying only enter. So when it's giving a suggestion, okay, in which you can only enter an array of dogs here. Okay, if you try to enter something else here, it will give an error. So under this you could have your my dog, and so I'm creating two dogs here. All right. Now, if you so it's an array of dogs which I have passed. This is basically, and let me make it look a little neater. Now you can see that. So I created an array of dogs and now I'm passing that. Okay. But if I try to pass new integer array, or try to say something of this sort, then it would start giving me error. It says that the method reverse dog in this type cannot be applicable. All right, sounds good to you? The generics is clear to you? All right, great. Great. So basically, there are two ways to type safing. One is while instantiating, other was while creating new my library, other was while extending. While extending also, we could enforce a single data type. Okay. Now, my dog library, you can no longer use it for storing integers or sorting or reversing an integers array. It can only be used for reversing. Okay. Now, the real use case, the whole reason why we discussed Java in first place, our mapper and reducer. Okay. Do you remember this class where we were we were creating a stub mapper class which was extending our mapper, and those were those strange objects. Okay. Those were these strange objects. It means I'm extending stub, I'm extending mapper and creating stub mapper, and I'm extending mapper for these four data types. And what are these data types used for? Let's have a look at how does mapper class look like. Okay, this is how the mapper class looks like. It has four data types: key in, key out, and value out. Okay, and those are the functions, those are the things it basically uses here and there inside this mapper class. If you go into mapper class, you will find that it internally creates a context based on this data type. All right, let me show you the code. So you have a look at this. It's a little too big. Now here, if you see this context, public class context, it extends a basic map context and forcing this context to be of these four data types. Okay, to be of these four data types, which means you cannot put anything other than these four things in while putting values into it. Okay. When we are passing four data types, does it mean that it can be of n? No, it has to be exactly in the same sequence. Okay, let me simplify it further. Now, let's imagine that my library class has another function, another function called public void, and let's say min. Okay, and it says e and e1. Okay, or what could I be, what could I do? Let's say swap. Okay. Hmm, what I'm just thinking what could I do. Okay, or let's say get first. Now here it takes an element of type e and it only returns e0. Okay, if array dot length greater than 0, then do this, and otherwise return null. And we say e, and here we define e like this. All right, now as you can see here, it has suddenly started giving us all these errors. Okay, right now we can get away simply by putting anything because we are not using any of the other function. Okay, all right, so everything works fine. What is the error here? Yeah, here it says my dog library extends my library, and here we could say integer. All right, so this way you can define things whatever you wish to do. Okay, you can have multiple data types defining your class. Next time, if you want to if you want to say if you want to use ml1 dot get first, then you can only pass an integer array. You cannot pass a1. Okay, so you can basically define multiple data types the way you have defined a single data types. All right, so we definitely have to provide all the data types. Yes, recordings will be available, no worries. All right, so this way, that is how the whole thing happens. So this context will only accept things which are of these data types. If essentially these two. Okay, sounds good to you, Seema? All right. So this is clear, right? Why we had those strange angular brackets? Yeah. So why not 4? Let's have a look at the class again. Where are these objects used? This is all documentation. Here, let's have a look. I'm saying create a context class based on these 4 variables. Okay. So here again, you can see the reader is being of 2 data types, key in and value in, while writer is of 2 data types, key out and value out. Okay. So for the mapper, the reader which is given to you in the form of context will have these two type safety, and output will be using these two data types. Okay. So basically, in context, when you say write, you will get only these two values, and you can only write in these two data types. And while reading the map function, if you see the map function, public class mapper and so on, the map function here says protected. It will give you only these two values. Okay, the significance of this map function is this, and it's the same map function which is internally used. This is an internal class, the run part, which is basically calling your map function here, map function provided here, and doing this. All right, so these 4 data types in our map say that our mapper will get data type input values in these two data types, key in and key value. It could be string or text and text, and we will be able to give only the data types of these two types, meaning we can only write inside our map function context dot write can only accept these two data types. Okay. So that is pretty much about generics. If you want to dig a little deeper, you can go ahead and study a little bit more about generics, but this should be good enough for our mapper reducer. All right. Do you have any questions for me, or did I skip anything which need to be addressed here? Yes. Go ahead, Seema. Okay. All right. So Seema's question is not really related to the Java session. Her question is, in there is a feature in Yahoo uh, which says trending now, and how would you implement trending now right now? Okay. All right. This could be done in multiple ways. Okay. So I think we can take it offline and we can discuss it. Maybe you can leave it on the forum and we can see the feedback of other people as well. And I'll also write my feedback over there. Okay. So Abhinav's question is, he's interested in exploring Mahout more. Will it be good to start with Spark, MLlib, or Mahout? I think it'll be good to start with MLlib, and either way, it'll be okay on both the sides. But the documentation for Mahout is better than MLlib, and Mahout is anyway getting moved onto Spark. They are basically about to release, and so I think documentation wise Mahout is far better than MLlib. All right. And also after yesterday's discussion, there were few concerns from the students saying they had few more questions. Okay. Some of the questions were left unanswered because the yesterday's session was a little too rushy. So I have planned for the next Sunday. Okay. Gather all your questions, gather all your points. If you want me to dig deeper into any of the points in Big Data and Hadoop, we can dig deeper into that aspect. All right. Same time, but next Sunday. I mean, coming Sunday. All right. So we'll inform all of you with the meeting details and then see. All right. Because the whole session looked to some of us as little bit rushy. Okay. And so that is why there are few questions left unanswered. Yes, please go ahead with your question, and that will also give me a little bit of time to think about the question and structure my thoughts. All right, great. Thank you very much for attending this session. And if there is any questions you have, feel free to reach out to us. All right. Okay. I too appreciate the thing that everybody is attending these sessions, and I'll try myself to uh, I'll try my best to make these sessions available online. And yeah. All right. Thank you, Seema. It's great to have students like you guys. All right. Bye bye. Thank you, Abhinav. Have a good day.